Okay, in this presentation we're going to look at numerical programming exercises. This is adapted from a well-known set of exercises used for people learning the Python package numpy. So there's 10 exercises here. They're short and sweet. What I'm going to do here is just adapt them to Julia, because in some cases they don't exactly translate immediately. So I'm just going to change them a little bit on an ongoing basis. Okay. Now, the first question in the original exercise sheet asks us to import numpy as np. We don't really have anything like that in Julia, so essentially what I'm going to do there is just print the working directory, just to sort of substitute in something that's reasonably close. Print pwd, print working directory, and so on. The second thing we have to do there, second exercise, is print the version of Julia, which is 1.6.1. Okay, now just as a quick remark, actually, something I should have noted is that it tells us that up in the top corner here that we are using Julia 1.6.1. And just as a quick remark, I probably should have mentioned this, I'm using Jupyter Notebooks for this particular exercise and this particular presentation. So moving along, create a null vector of size 10. So here I'm going to take that to mean a vector of zeros. Okay, so the command there is simply zeros, and I need 10 of them. Okay, that's good. That's all we need. On a regular ongoing basis, it's good to check all the types of the objects you're working with. So type of is also is always something worth keeping an eye on. Exercise 4 is create a null vector of size 10 and set the fifth element to 1. Now this exercise is fairly similar. All we have to do here is use a bit of indexing and assignment there. Z5 equals 1. Remember that Julia is 1 indexed. Okay, so 5 means the fifth element. Okay, let's just run that. Just as a remark, there are lots of really useful commands like push first, pop first, insert at, delete at, that are also very useful for these type of exercises. But anyway, we'll keep going. Okay, so create a vector with values ranging from 10 to 99. Okay, well, first off, what we could do is set up a range. I'm just going to do this here, 10 to 99. That sets up a unit range. Okay, but I just need it as a vector, so essentially I'm just going to create it there as a vector. Okay, so we have a 90 element vector there of integers, and that's exactly what we want. Let's just check, is everything in order? Yes, it is. So check the type of there, just again, sort of just a good habit. So exercise 6. Create a 3x3 matrix with values ranging from 0 to 8. Okay, so that will have 9 integer values there. So how we might one approach for using that is, again, set up a range there, a range object, a unit range object, and just reshape it with 3 rows and 3 columns. So let's see how that would look. Okay, you notice that the type is not a matrix. So we'll have to sort of sort that out, okay? But what we can do is just actually specify it as a matrix here. So turn that into a matrix Z, okay? And you might have to resave it, okay? Just in case, there's the transpose command, which means that if you want to have it 0, 1, 2 on the top row, you don't like the orientation there, so what you could do there is just transpose it. Okay, so that's just in case. It doesn't really tell us which way there to go in, it just has to say 0 to 8, so you have all your options open to you there. Now, question 7. Find indices of non-zero elements from this vector here, 1, 2, 0, 0, 4, 0. Okay, so what we want returned to us is the values 1, 2, and 5. Okay, so just actually what we're going to do here is check each one of them to see which of them are greater than 0. Okay, so 1, 1, 0, 0, 1, 0. Now, essentially, this is essentially a Boolean operation. So it's true or false, really. So 1, 1, 0, 0, 1. Okay, so and essentially that is the basis of what we're about to do. So we want to find the indices of every case element where that is actually non-zero. So we use find all, and then the comparison or the logical operation or whatever it is in terms of inside as an argument to find all. Just remember the little dot there, because essentially we're comparing a vector, each element of a vector, to 0. So we need that little dot there. That's good. It used to be called find, by the way. The command used to be called find. Now, create a 3x3 matrix. We're nearly done. So what we have to do here is set up using linear algebra. So I have this package sort of installed. Okay. So the command there is capital I. So it's a 3x3 matrix. So I just have to specify the numbers of rows or the number of columns. There we go. Previously, the command used to be known as I, as in eyeball, but they put it back to capital I. Okay, so people from using MATLAB might be familiar with that already. Okay, so I'm just going to check the type of this. Okay, so I'm just going to set up a little matrix here, A, and that's a 3x3 matrix. Nothing unusual about that. Just see if they multiply each other out. Okay, so it's just to sort of check the types. Does that identity matrix work if you try to multiply it with a matrix? And yes, it does. Okay, so the type, there's no issues with regards to type there. Okay, so that one's fine. So again, the command there is simply capital I and the number of dimensions, the number of rows or number of columns. So create number 9. Create a 5x5 matrix with values 1, 2, 3, just below the diagonal. Now this is a tricky one. Okay, so first off, let's just see how we might create a diagonal matrix. Diagonal, and just specify the values there, 1 to 4. That seems to be straightforward enough, but just as a remark, that's on the diagonal, not below the diagonal. Okay, so that's not what we want. What we want is a diagonal matrix, but we have to, and this is a very useful command for doing stuff like this. So what we're going to do here is specify the diagonal index, if you get me. So the main diagonal would be 0. Okay, but the next diagonal above the main diagonal will be diagonal 1, diagonal 2, that's diagonal 2 there, and that would be diagonal 3, and so on. Okay, so it's the displacement from the main diagonal is this first argument here. Okay, now because we are going below the diagonal, what we need is the negative displacement there. Okay, so if we're going below it, we go -1, -2, and so on. So that's sort of what we need. Okay. Just this command is actually quite interesting because you can actually have multiple elements on the diagonals, or multiple diagonals specified, as long as yeah, there we go. Diagonal 1 has the values 1, 2, 3. Diagonal -1 has the values 4 and 5. You'll notice, I was about to say it, but actually it was not going to be the case, that they don't actually necessarily have to be of equal length. These the diagonals, they don't actually, the value specified. Okay, so we actually end up with a spare 0 down here. Okay, so anyway, yeah, let's just go back to what we're looking to do here. This is what we're asked to do. That's a 5x5 matrix with 1, 2, 3, 4 just below the diagonal. Right. Just as a quick remark, if people looking at this and they've seen this command before. The notation and the specification of this command has been updated. This function has been updated recently. So just actually, this is a new way of using this command. Finally, an easy one to finish up with, because for Julia, is create a 10 by 10 array with random values. Simply what we'll do here is specify our random values with rand. Okay, that's it there. Okay, it isn't easy to look at, but trust me, that's what we want. Let's just go to a 10 by 10 two-dimensional matrix just to see one of them. There we go. Okay, so those are numbers, randomly selected numbers between 0 and 1. Alright, that's grand. We'll leave that there.